Hello, this is Ms. DB, and today we're going to learn about polynomials. This is Chapter 7, Section 6 in your textbook. Our objectives are to classify polynomials and write them in standard form, and to evaluate polynomial expressions. First of all, some vocabulary. A monomial, with the prefix mono, is a number or variable or a product of numbers and variables with whole number exponents. One term only. No, it is not separated with plus or minus signs. It's just one term. It also cannot have negative exponents, and it's not going to be written with a variable in the denominator. The degree of a monomial is the sum of the exponents of the variables. If it's a number, a constant, like 5, that has a degree of 0. But anything else, if it's just x, that would have a degree of 1. In this next box, negative 7xy, that would have a degree of 2 because you'd add the two exponents together. In the next one, this one would have a degree of 4 because the exponent has an exponent of 4. The variable has an exponent of 4. Let's find the degree of each of these. In A, you would add the two exponents together. So 4 plus 3 is 7, so the degree is 7 for A. In B, we would add the exponents of 1 and 1 together to get 2. Remember that any variable without an exponent really can have an exponent of 1. And in the last one, that is a degree of 0 because a constant has a degree of 0. Remember that the terms of an expression are the parts being added or subtracted, so they're separated with plus or minus signs. Let's look at the degree of each of these monomials. These are from your worksheet. The first one, number 1, the question on the worksheet is slightly different, but we're going to find the degree for number 1 so that you can answer question 1. We have to add the variables, so this one would have a degree of 1. The y has a degree of 3, so 1 plus 3 is 4. In number 11 from your worksheet, the degree would be 3 plus 5, or 8. And in number 12, you would add the 2 plus 2 and get a degree of 4. A polynomial is a monomial, or a sum of difference of monomials. It's more than one term being added together, more than one monomial being added or subtracted. The degree of a polynomial is the degree of the term with the greatest degree. You don't add them all together. You just find the degree of each term, and then you find the one with the highest degree. That is the degree of the whole polynomial. The greatest one wins. So in this example, for number 11, we have to find the degree of each polynomial. Letter A. So we have 11x to the 7th plus 3x to the 3rd. You find the degree of each term. You don't combine them. The first term is 11x to the 7th. That has a degree of 7. The second term is 3x to the 3rd. That has a degree of 3. The bigger of these is the 7. So the degree of the whole polynomial is 7. The next one, we have 1/3 w squared z plus 1/2 z to the 4th minus 5. Find the degree of each term. The first term would have a degree of 2 plus 1, or 3. The second term would have a degree of 4, because the exponent is 4. And the last term, the minus 5, is a constant, so it has a degree of 0. The greatest of these is the one with a degree 4, the 1/2 z to the 4th. So the degree of the whole polynomial is 4. So you just find the greatest and leave it at that. Here's some from your worksheet. In number 12, we have x to the 5th plus x to the 5th y. We have to find the degree. So find the degree of each term. Our first term, x to the 5th, has a degree of 5. The second term, x to the 5th y, has a degree of 6 because we would take the 5 plus the 1. The greatest of these is 6. So that's the degree of the polynomial, 6. In number 13, we have to find the degree of each term. The first term has a degree of 1, 2, 3, 4, 5. 2 plus 3 is 5. The second one has a degree of 4, and the third term has a degree of 0 because all constants have a degree of 0. The greatest of these is 5, so the degree of the polynomial is 5. The terms of a polynomial may be written in any order, but if you want to write it in standard form, then you write it in descending order, which means that the highest degree would go first, and then the next lowest degree and the next lowest degree, ending up with any constants. When you write it in standard form with the highest degree term first, the coefficient, which is the number in front of the variable, that's called the leading coefficient. And you'll often have to identify that. All right, so we are to write this polynomial in standard form, then give the leading coefficient. So standard form means that we put the highest degree term first. So the degree of the first term is 1. The second term has a degree of 5. The third term has a degree of 2, and this one has a degree of 0. So the greatest one of these is the 5. Note that the minus sign in front of the 7x to the 5th stays with it. It's negative 7x to the 5th now. And then it's the next lowest or next greatest one would be 4x squared, and that has a plus sign in front of it. So we write plus 4x squared, and then plus 6x because that's a positive unless there's a negative there. And then finally the plus 9 gets written at the end. So that's standard form, negative 7x to the 5th plus 4x squared plus 6x plus 9. The leading coefficient is the number in front of the first variable once you write it in descending order, once you write it in standard form. So the coefficient is negative 7. Not negative 7x to the 5th, not negative 7x, negative 7. All right, here's another example. Write this in standard form and give the leading coefficient. So remember, for standard form, we write the highest degree term first. So that one would be the y to the 6th. That has the greatest degree. It has a degree of 6. The next highest one would be the degree of 2. That's the plus y squared. And then finally we'd have the minus 3y. That only has a degree of 1. Now that you have it written in standard form, the number in front of the first term variable is the leading coefficient. If there's no number in front of it, like in this example, then it's 1. The leading coefficient is 1. So here again is a reminder that if you have a variable with no coefficient, it really has a coefficient of 1. You just don't have to write it. Either of these would be correct. Both of these have a coefficient of 1. Here's another example. Write the polynomial in standard form, then give the leading coefficient. So let's see. This has a degree of 1. This one has a degree of 2. This one has a degree of 5. This one has a degree of 3. Remember, we're only looking at the exponents in order to determine the degree. Oh, this one has a degree of 0. Sorry about that. It's got no variable, so it has a degree of 0. The highest of those is the x to the 5th. So you're going to write x to the 5th plus 9x to the 3rd minus 4x squared. See again that this minus sign stays with this. It's one piece. And then finally plus 16 at the end. The first term is the x to the 5th. There's no number in front of it, but we know that that really means it has a coefficient of 1. And you can put a 1 there if you want. So the leading coefficient is 1. Here's one from your worksheet to do. We have to find the leading coefficient, so we need to write it in standard form. So we need to find the degree of each one of these terms. So the first one would have a degree of 3. Next one would have a degree of 4, and the last one would have a degree of 5. So if we write that in descending order, we would get negative 6x to the 5th. Note that this minus sign goes with it. Minus 5x to the 4th. Again, this minus sign is part of that term. Plus x to the 3rd. And the leading coefficient then would be negative 6, the number in front of our leading term, our first term. Okay, we can also name polynomials based on their degree and on how many of terms they have. It's helpful to be looking at a table when you do this. There is a couple of these tables on your worksheet. So we can name it by degree with these names on this first table, and we name it by number of terms on the second table. So 5n to the third plus 4n. It has two terms, so it's a binomial. It also has, let's see, what is the degree? The degree of this polynomial is 3. Remember, we just used the greatest of the degree of each term, and that's 3. So that is a cubic. So you would say for this first problem that it is a cubic binomial. In the next one, 4y to the 6th minus 5y to the 3rd plus 2y minus 9, it has a degree of 6, because this one's 6, this one's 3, this one's 1, this one's 0. 6 is the greatest, and it has 1, 2, 3, 4 terms. So a degree of 6, is just a 6th degree, and terms of 4 is just a polynomial. So there's only special names for certain ones. After a certain point, they just call them polynomials and so many degrees. So this one we would just say is a 6th degree polynomial. This one you should know without even looking. This is a monomial because it only has one term. And if it has a degree of 1, we call it linear. So it's a linear monomial. Here's a few more. One of these is from your worksheet. The other two are just examples. A is just an example. We have x to the third plus x squared minus x plus 2. 4 terms and a degree of 3. So you can look at your table. This is going to take me a minute. And it's a degree of 3 is cubic, but 4 or more, we just call it a polynomial. So it's going to be a cubic polynomial. In B, if you just have a number, that's just called a constant, and it's only got one term, so we call it a monomial. So we would call B a constant monomial. And then the last one is from your homework. And this one is negative 3y to the 8th plus 18y to the 5th plus 14y. It has 3 terms, which we call a trinomial. And its highest degree is 8. And if you remember, we don't have a special name for a degree of 8. We just call it like 8th degree. And if it has 3 terms, we call that a trinomial. I covered that up a little bit. So 8th degree trinomial for 23. Okay, finally we have an application problem that we will be using with a polynomial. A tourist accidentally drops her lip balm off the Golden Gate Bridge. The bridge is 220 feet from the water of the bay. The height of the lip balm is given by the polynomial negative 16 t squared plus 220. So we're going to use that equation where t is time in seconds. How far above the water will the lip balm be after 3 seconds? All we have to do here is substitute t equals 3 into that polynomial and simplify it. So we put the 3 in, and then we follow our order of operations, and we would square that and get 9. So we'd have negative 16 times 9 plus 220, then take negative 16 times 9, which is negative 144 plus 220, and we'll find 76. So the question was, how far above the water will the lip balm be after 3 seconds? And we found that it will be 76 feet from the water. There's a problem sort of like that on your worksheet, so don't skip it. It's not that hard. Thanks very much and have a wonderful day. Let me know if you have any questions.